Hey there, and welcome to your video on topics 7.3 through 7.5. That covers thermal inversions, atmospheric carbon dioxide and particulates, and then indoor air pollutants. So let's go ahead and get started. The very first part that you need to look at for thermal inversions is on this page. Basically, here's the story with this. A thermal inversion is a weather pattern that makes air pollution worse to the point that it can be lethal. So here's what I want for you to imagine. Uh, what they're not showing you in these pictures are what the weather normally looks like, which is this. Normally you have uh, warmer air to cooler air, and so the air rises and then it dissipates. In this particular scenario, what happens is that you have cold air. It's cold. The whole layer from the ground to the middle of the troposphere is all cold, and then you have this layer of warm air called an inversion layer that comes in, like the lid to a pot. All right, so let me go ahead and extend that metaphor here a bit, which is thermal inversions have a very specific set of precursors in order for them to be able to happen. There are only two land formations in which thermal inversions become really problematic. The first one and the most common is this one. Basically, you have a city which creates air pollution that is in a valley, which basically means it's in a bowl. Or you have a city that sits against an ocean where you have a mountain range behind it. So let's say cities in India that are up against the Himalayas, you're going to have this situation, and then you have cities in Chile that lay between two mountain ranges that have this particular situation. Um, when is it cold? It is going to be cold, in the winter time, and then you have this warm layer of air that, for a variety of reasons you don't need to understand, comes sliding in and just acts like a lid. How long can this last? Days to weeks. And so it means that all of the air pollution that's building up that normally gets, it's not great breathing this stuff in during the day, but it also dissipates. It's at a level bodies can tolerate. Here, because it's not allowed to dissipate, the concentration increases. This is like bioaccumulation, except in air. Obviously, you can't call this bioaccumulation because this isn't a living creature, the air, but it's the same idea. So what is normally just little dribs and drabs of air pollution, which again is not great, gets stored in the air because it doesn't get a chance to dissipate, to circulate out, and so it builds up around this city. So let's go ahead and take a look at the questions now that I've explained this. So I've already explained the three layers of air associated here, the two geographic formations. Explain how it happens, include temperatures and times of year conditions. Times of year conditions is applicable. So here's what I mean. What you've got here is it's either called a temperature inversion or a thermal inversion. Those two are equivalent terms. So you can see that you either have this happens in the wintertime or now again, why does it also need to be sunny? Because remember, photochemical smog forms when there is sun around. Good, we've already gotten to that already. All right, so and then also you have this situation where you have the ocean breeze kind of acts like another wall. So do you make sure that you have read all of this? I'm just skimming to make sure I picked out all of the most important parts here. So yeah, that's mostly winter time. Winter yet sunny is normally when this occurs. All right, so do you make sure that you're absorbing everything that's going on here? Why are thermal inversions an issue in cities with pollution that's otherwise not a problem? I went over that. Give 2 specific examples of how thermal inversion can lead to human health problems. That's all right here. Obviously, again, being air pollution, you have lung irritation, increases irritation due to pre-existing conditions like asthma and bronchitis and emphysema. But also, don't forget that this also can lead to things like lowering your resistance to other secondary infections because everything is already aggravated. It can aggravate heart disease. Don't forget that having really irritated lungs can trigger, a heart attack. So definitely be familiar with all of these. If during the national exam you can't remember anything, air pollution, lung irritation, that pretty much should be a good connection for you to make. And that's pretty much the entirety of thermal inversion. Atmospheric CO2 and particulates, we pretty much talked about this already, so please just make sure that you go back and revisit carbon dioxide. Make sure that you revisit natural sources for this stuff. That and particulates is right here. And then just kind of read what I have there in your questions. I've kind of pretty much told you what you need to know here. So we're going to go ahead and kind of jump to indoor air pollution and talk about a variety of this stuff here. So I'm going to go ahead and turn to page 613. So, unlike outdoor air pollution, which is usually more of a problem in developing countries than developed countries, because most developed countries these days do have laws that regulate pollution output, developing countries are the ones that suffer from outdoor air pollution. Indoor air pollution, however, is a universal problem, and it's different kinds of indoor air pollution depending where you are. So let's break it down. What practice in less developed countries exposes people to dangerous levels of particulate air pollution? What types of fuels are cited? This is super simple. When you use biomass or coal to burn for heat and light, and you do not have a properly ventilated home, that particulate matter and carbon dioxide and carbon monoxide, and in the case of coal, heavy metals, build up in your house. And especially if you look like this, you're kind of hunched over that cooking flame for hours a day, also a problem. Now you may think, well, geez, why don't people just build a chimney? And there are a lot of answers to that. The first one is it is a area in which people and animals can get into your house. It's also a way in which rain can get into your house. And simply having a chimney doesn't mean that the smoke escapes. You have to create a what's called a draw. There's something in a chimney called a flue. It's kind of a flap that you adjust so that you create an airflow. It's the same way that if you only open one window in your car, you kind of get that flapping. If you really want the air to circulate through your car, you have to open 2 windows so that you get that cross breeze. So it's also a technology issue, but there's a safety issue. There is and even though if you're outside, you're still kind of hunched over this. I know this is indoor air pollution, but this is a problem no matter what. Now, your book does not discuss this, but combustion does not only happen at home. Combustion can happen in small industries that take place maybe in a couple of rooms in a building. Where there are no laws that protect human safety, no OSHA laws, and so this kind of burning without appropriate ventilation is also an issue in those industries. What are the 4 most dangerous indoor air pollutants in more developed countries like the U.S.? It's right here. Formaldehyde, emitted from many building materials and various household products, including, I might add, dry cleaning fluid, radon, particulate matter, and then obviously tobacco smoke. All right, so be familiar with the list of other indoor air pollutants that can be problematic in more developed countries. You've got a list that's right here. Um, with the national exam being the way that it is right now, this is kind of, having just a couple in your head, I think will be plenty. This is an interesting list for you personally because moving forward in your life, these are kind of nice things to know about. Part of what I will be talking about is how you can make sure that you don't have to suffer the consequences of allowing these to build up in your home. The next one, asbestos and mold are important indoor air pollutants. We will talk about those in the supplemental PowerPoints, which is what I would normally have covered in class. All right, you want to go back to page 604 and 606 to revisit the effects of carbon monoxide and lead on human health. Look at figure 19-15 to note how they can become indoor air pollutants. So this is a wonderful graphic. This may be one of the many pages that I have you guys kind of bookmark before the national exam just so that you have it. For your own edification, this kind of tells you where there can be issues. Now, remember, because carbon monoxide is an odorless gas, really the only way to know that you have problems with this in your house is to have a monitor that will beep at you when there's a problem here. But I will tell you, if you're ever in a house or in a car and you feel kind of woozy and disoriented after you've been there for a little while, you may have carbon monoxide poisoning and you need to get it checked out. Something to keep in mind, and I'll emphasize this again later, is that radon is a heavy gas. When it seeps up through cracked foundations, again, we'll talk about this in a second, it just sits here in the basement, which is why you don't see it being a problem in the rest of the house. Why do I bring this up? Because almost all of these problems with the stuff building up in your house can be solved through one simple method, and that is open your windows regularly, like once a week. I, in my own home, once a week, make sure I throw open all of the windows, even when it's hot outside, for a couple hours to kind of let the air flow through to decrease the concentration of this stuff in my house. This is the same reason why I change bedding regularly, wash my sheets. If I can't get my comforter washed, I'll even just, lay it outside on a couple of chairs so it can air out during the day. Stuff builds up in your house, and so you want to make sure that you allow it to go ahead and reduce in concentration. Okay, so what are the cluster of symptoms collectively known as sick building syndrome? They are right at the bottom of page 613. It's all of this. This is work can literally make you sick, and it's for a variety of reasons. It can be everything from, think about business buildings. Nobody's ever opening those windows ever. And so cleaning solvents and the solvents that are in new carpet and whatever else comes into that building stays in that building. You also have mold, and mold creates spores that can also get into your lungs and cause problems. All right, so I already talked about circulating air. And again, remember, you can't open a window. It has to be, circulation is an active thing, and so you have to have that cross breeze. Why do I bring that up? I was on a question, grading a question on the national exam, where simply saying opening your window, not enough. All right, so what is radon? Radon is a colorless, odorless, radioactive gas, and this is really key, that is produced by uranium-238. And remember, uranium is found naturally in soils, and so when it breaks down, it can release this gas. And if you have cracks in your foundation, this is especially true of homes with basements, it seeps up, but then because it's heavy, it can just sit there and build up in your basement. Now, why do you care? It is the second leading cause of cancer in the United States, lung cancer, excuse me. The first being tobacco, but the second being exposure to radon. This is not in your book, this is just for your personal edification. I will also tell you that there are some granite countertops that will release low levels of radon as well, but it's again one of those things that If you have an active air conditioning system that circulates air out, you're in good shape. Why do I keep bringing this up as heavy? Because you can't just open a window and have it fly out. You have to actually create an active system where you have an air pump that takes the radon out of the house. Now, how do people know they have radon? You actually have to get alarms put in. There are a lot of places in the north and Midwest where having radon alarms in your house just kind of comes with the territory. But this very specifically is the second leading cause of lung cancer in the United States. So, yeah, all right, so that was a really short section, so there you go.